Hey guys, Mr. Riz here. So we are going to finish off P6, which is going to be our last section of the pre-calculus review. So this is the second part here. We're going to be looking at Pythagorean Theorem, and really what we'll be looking at is, or not trigonometry, but we're going to use the Pythagorean Theorem. So some of the stuff you can use using the unit circle, but we're going to show you how to figure it out without the unit circle. So if I want to find the arc cosine of negative radical 3 over 2, what I'm asking is, okay, remember, arc cosine working from the inside is like what angle gives us a negative radical 3 over 2 for the sine? So what angle has a sine value over y that's negative radical 3 over 2? And once we figure out that angle, what's the cosine of it? Another way to think of it using trigonometry is that SOHCAHTOA, sine, cosine, tangent, is really just sine is the opposite of a hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. I want to double check that you guys are seeing this. No, you guys are probably not. There we go. So let me write that out again. I don't think you guys saw that. So the sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. So when we say the arc sine, really we're naming the opposite and naming the hypotenuse. So what we can do here is to draw a little right triangle, and we're going to label the opposite angle negative radical 3 over 2. Now technically if it's negative, this would have been upside down. If you label it negative, that's going to be fine. Just use it later on. And the hypotenuse would be 2. Since we want to find cosine, cosine is asking us to find the adjacent over hypotenuse. So we know it's going to be something over 2 because the hypotenuse is 2. We got to find the adjacent now. So we can do Pythagorean theorem to find that adjacent side. So we can go, okay, a squared plus negative radical 3 squared equals 2 squared. So a squared would plus, all right, if I square negative radical 3, the negative goes away, the radical goes away just as 3. 2 squared is 4. So I can minus 3, a squared would equal 1, take the square root of 1, that is 1. So this a side would be 1. So the cosine of this triangle here that makes this up is 1 over 2, or 1/2. Okay, and we'll just stick with the positive answers for this class. We won't have to look at scenarios where we could potentially have a negative as well, but so we'll just stick with positives, 1/2. So same thing, if I got the tangent of the arc cosine, so I like to make a little right triangle here. And cosine is 1/2, or cosine is adjacent over hypotenuse. So that means our adjacent side would be 1, our hypotenuse would be 2. All right, now tangent is opposite over adjacent. So it's going to be something over 1. Let's find this opposite side here, and we typically call that b. So 1 squared plus b squared equals 2 squared. Or 1 plus b squared equals 4. This might look a little familiar. B squared equals 3. So this opposite side is the square root of 3. I think the Amazon guy is here. So the tangent is opposite, which is radical 3 over adjacent, and that just simplifies down to radical 3. Okay, we'll do a couple more here so you guys can get the hang of this. All right, now what happens when we don't have numbers that are nice on the unit circle? We still use the right triangle. All right, secant is the flip of the cosine. Cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent. So our hypotenuse is 7, our adjacent side is 4. Sine, we got to find opposite over hypotenuse. Thank you. Or opposite, yeah, over hypotenuse. So we got to find the opposite here. So 4 squared plus b squared equals 7 squared, or 16 plus b squared equals 49. We can subtract the 16 from 49, and what is that, 33? So b is radical 33. So the sine of this would be opposite radical 33 over hypotenuse 7. And that's it. So sometimes we get really ugly numbers. That's okay. All right, last one, arc secant of radical 10. So same thing, we can make this a fraction by making this radical 10 over 1. So that means our hypotenuse is radical 10. the adjacent would be 1. Cosine, well, cosine, we just need to find adjacent over hypotenuse, so there's no need to find the sine, so that's kind of nice. So it would be 1 over radical 10, and that would simplify to radical 10 over 10. There's the answer. Okay, so we're going to continue on with this concept here and just expand on it a little bit more. So if we have to solve an equation for x, we can do the same thing. We can use our unit circle here, and we can find these locations. So looking back at a unit circle here, if I wanted to get, well, we'll recall, but we got to do the first step actually. If I wanted to get rid of the sine, get the 2x plus pi alone, I'd have to do the sine inverse of the other side. So the sine inverse of 1/2. So go ahead and take a look at the unit circle. We are going to get 2 answers here. Where does the sine, or the y, equal 1/2? All right, so take a look at the unit circle. Where is that? Okay, so that would be at pi over 3. It's 1/2. And 2 pi over 3. So now that we got that, we have 2 answers. We're going to get 2 different answers for x. So we're going to do the same steps here. We'll subtract pi from pi over 3. So you almost have to think of this almost like fractions. So we got 1/3 pi minus a whole pi. We'd have negative 2/3 pi, or negative 2 pi over 3. And we'll divide by 2. When you divide a fraction by 2, it's the same thing as multiplying by the denominator by 2. So we'd get negative 2 pi over 6, or actually we could have just simplified that. That is negative pi over 3 for this answer. We're going to do the same steps over here. Maybe we'll do a little bit better when we divide, but we might not have to. All right, if I subtract a whole pi, 2/3 of a pi minus a whole pi means I have a negative pi, or negative 1/3 pi. And then I'll divide that by 2. I get a negative pi over 6. So we get 2 answers. All righty, so the next one here, how do we solve this one here? So the same thing, if I want to get this x plus 3 over negative 4 by itself, I'm going to have to take the tangent inverse of 1. So look, there are 2 times on the unit circle where the tangent is equal to 1, or tangent, remember, is the slope. When does the slope equal 1? Go ahead and look. We'll get 2 times. The one time is when pi is over 4. The other time is at 5 pi over 4. So we're going to go ahead and solve both of these. Let's take care of this negative 4 on the bottom. I'm going to multiply the other side by negative 4. So if I multiply pi over 4 by negative 4, I get a negative pi. Then I'm going to subtract 3, and pi and 3 don't really work together, so we get a negative pi minus 3, and that's the answer for the first x. Now the other side here, if I multiply 5 pi over 4 by negative 4, I get a negative 5 pi, and subtract 3, and we get a very similar answer, negative 5 pi minus 3. Now technically these answers would repeat, but once again in this class we only care about things that are on the unit circle, so those are the 2 answers in a unit circle. There's an answer, and that's another answer within the unit circle, going both positive and negative. Okay, one more section here. Let's get real crazy and kind of combine the 2 things we just did. Oh, actually 2 more things. All right, now how do we simplify these in algebraic form? Okay, what we want to do is to use our right triangle here and kind of do what we just did in the last 2. We have a tangent here, and tangent in SOHCAHTOA is the opposite over the adjacent. So I'm just going to set this up here as opposite is 2x, the adjacent is 1. If I find the secant is the hypotenuse over the adjacent, so I got to find the hypotenuse. All right, so let's find this side here, c. So I would have 1 squared plus 2x squared equals c squared. So I can get an expression for c here by saying, okay, this would be 1 plus 4x squared equals c squared. So I can say c equals the square root of that, 1 plus 4x squared. So now when I set up my secant, I can just say that this is 1 plus 4x squared, the hypotenuse, over the adjacent, which is 1. So the answer for this would just be 1 plus 4x squared. Okay, we'll keep doing these, more practice. So these are kind of things that you might have not gone over. And so we'll just do a couple more. So next one, the secant, or the tangent of the arc secant of pi over 6. So secant is the hypotenuse over the adjacent. So we'll call the hypotenuse x. The adjacent 6. Tangent, we got to do opposite over adjacent. So we do need to find this opposite side here. So set it up. 6 squared plus b squared equals x squared. We're going to get the b by itself. So that's 36 plus b squared equals x squared. We'd have to subtract the 36, so x squared minus 36, and then take the square root of that. And we just leave it as it is because you cannot simplify that at all. The square root of x squared minus 36. All right, the tangent is opposite radical x squared minus 36 over adjacent 6, and that does not simplify. We can't break anything outside of the radical here. 6 doesn't distribute through there or anything, so we just call it a day with that one. All right, cosine of the arctan of x to the 5th. We'll make that x to the 5th over 1. Tangent is opposite, x over 5th over the adjacent 1. Let's start working on a cosine, which is adjacent over hypotenuse. So we do need to find this hypotenuse here. So 1 squared plus x to the 5th squared equals c squared. So we get 1 plus x to the 10th equals c squared. So c is the square root of that. All right. Cosine is the adjacent 1 over the hypotenuse, radical 1 plus x to the 10th, the square root of that. Now, if we want to get fancy, we can multiply by radical 1 plus x to the 10th over radical 1 plus x to the 10th. And the correct answer would be 1 plus, well, yeah, radical 1 plus x to the 10th over 1 plus x to the 10th. If you put this answer down there, I'll be fine, but there's the simplified version of it. Okay, and then lastly here, we got the secant, the sine of the arc sine of 5 minus the cube root of x squared. Okay, looks pretty crazy, right? So if I honestly give you this, double check what's going on. Make sure you know what happens with sine and arc sine. They are opposite functions of each other. They are inverse functions, so they actually cancel each other out. So don't get too confused. You should know here that this just simplifies to 5 minus the cube root of x squared minus 9. These two functions would cancel each other out. We would set up a triangle with our opposite over our hypotenuse and then try to find the opposite on the hypotenuse, which is just that. All righty, one more section to go. Longer review here, but let's get to it. So let's see, we want to find the equation for x. We're going to find the arc sine of radical 4x when it equals the arc cosine of radical x. All right, so let's just start on the left. I always like to clean up the left a little bit more. If I wanted to get rid of this sine, arc sine, I would have to take the sine of the other side. So I get radical 4x equals the sine of the arc sine. Remember arc or arc cosine. Remember that's the same thing as the cosine inverse, just two different ways of radical x. Well, we just did problems like this one here. Let's set up our right triangle. And cosine is opposite, or no, adjacent, so radical x over hypotenuse 1. If I want to find the sine of this, okay, I need to do opposite over hypotenuse, so I got to find this out. So off to the side here, I'm going to do Pythagorean Theorem. Radical x squared plus b squared equals 1 squared. So x plus b squared equals 1. B squared would equal 1 minus x, and so this opposite is radical 1 minus x. So that means the sine of this triangle here that we made is radical 1 minus x over 1. or I'll just leave it as radical 1 minus x. Now, the reason why that is important is because now we have an expression with no trig functions anymore. We just have radicals. Well, to get rid of radicals, we'll just square both sides. So if I square that, it becomes a 4x. If I square this, it becomes a 1 minus x. And we can solve here. I can add x over, so 5x would equal 1. And so that x would equal 1/5. So that's the value. If you plug it in for both of those, we'd get the same number. So it starts out really crazy, but then it ends simple. So same thing here. If I want to get rid of this tan and make this just radical 2, I would have to take the tan of the arc cosecant of radical 5x. All right, so let's see, in our right triangle, arc cosecant, this would be the hypotenuse, radical 5x, over the opposite 1. Since I'm finding tan, I do need to do opposite over adjacent. I got to find this a term here, this adjacent side. So let's see, a squared plus 1 squared equals radical 5x squared. So a squared plus 1 equals 5x. A squared equals 5x minus 1. And so that adjacent side is radical 5x minus 1. So our tangent would be the opposite 1 over the adjacent radical 5x minus 1. So now we have our expression set up. Now this one looks a little bit different because we have a radical in the denominator. But don't get too scared, because if we square both sides like how we squared both sides on this one, we're going to cancel out the radicals. And technically the squaring we do here is also square 1. 1 squared is 1, and radical 5x minus 1 is 5x minus 1. If this was a number like 4, we would have to change that to 16. We're squaring everything here, so we square all 3 parts. Now, the next thing we can do is we can kind of think of this as like 2x over 1, and we could crisscross applesauce here, cross multiply. So I'll distribute the 2x, and we're going to get 10x squared and minus 2x, and equals the other side here, 1. Now this just became a quadratic, and we have to set this up. So 10x squared minus 2x minus 1 equals 0. Can we factor this? What two numbers multiply together to give us negative 10, add together to get negative 2? If that was a 3 in the middle, we'd be all lucky charms here. But that doesn't work, so let's make the worst problem even better by doing quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times 10 times negative 1. So that'd be positive 40 over 2a. All right, so we get 2 plus or minus the square root of 44 over 20. 44 breaks down to, we get 2 plus or minus this, we can factor out a 4. So 2 radical 11 over 20. And so this just simplifies down to 1 plus or minus radical 11 over 10. If that one was a little tricky, I don't blame you. I probably could have made this number a 3, and this would have been way easier. Yeah, maybe I'll do that next year, change it. This is the section I'm assuming we'll go over quite a bit. These are the tough problems. You probably didn't get to review those last year with everything going on. Okay, so we're going to end this because I am getting rid of P7 because I definitely know that you guys didn't get close to that at all the year before. You probably didn't. You might have, depending on who your teacher was and what they felt comfortable giving you guys online. But we'll go through this. So after this, we have the test coming up. So we'll start reviewing, and then we'll be taking the test afterwards. All right, you guys have a great day. I'll see you guys next time. Good luck.